Life is a natural phenomenon known today exclusively on Earth. Life is characterized by the fact that it can reproduce itself identically, the presence of water, a metabolism, and an ability to maintain physical and chemical parameters. The Earth was formed 4.5 billion years ago. No form of life inhabits it in its primitive form. It does not look like the planet we know today. Covered by a thick, extremely hot atmosphere, the Earth has an orange hue. Its surface is totally unrecognizable. Everything is so quiet, so empty, so silent. Dear traveler, good morning. Today we are going to explore the past of our planet to follow the journey of life. Before leaving for a new adventure, remember to like the video and subscribe to the channel so you don't miss anything. Thank you, and have a nice trip. With time, the Earth cools down. The water contained until then in its primitive atmosphere becomes liquid. The hydrosphere appears. It starts to rain. Water fills the depressions and the oceans are formed. Life appeared on Earth 3.5 billion years ago, about 1 billion years after its formation. At the beginning, in the form of simple, unicellular organisms, they evolve in an aquatic environment and are small in size, about a few tenths of a millimeter. Little by little, the cells group together and move closer together. They absorb sunlight, water, and gas. They develop and invade the seabed. In several million years, the cells perfect themselves and gather. They will form multicellular beings of various shapes and sizes, larger than the unicellular ones, a single nucleus not being able to control a too large quantity of cytoplasm. Multicellular organisms see their cells associate in tissues, which will allow them to accomplish functions. 540 million years ago, a real explosion of diversity occurred, the Cambrian explosion. The ideal conditions are met for the evolution of many species of marine animals. The oceans were filled with living creatures similar to jellyfish, shrimp, and worms. Some species kill each other and get bigger and bigger. From the abyss to the surface of the water, the aquatic world is teeming with life. Green seaweed grows in the shallow waters and will evolve to become the first plants to grow on land. Mosses cover the land areas. Today, our planet has an extraordinary wealth and diversity of animals and plants. And yet the history of life is not a calm one. The latter has not been spared, and it has undergone great upheavals, having each time consequences on its evolution. Today, the forces of nature seem calmer, and the Earth seems to have found its balance. And yet, a species is wiped out from the planet every 20 minutes. The equivalent of 7 soccer fields are deforested every hour. After the 5 great cataclysms that led to the 5 greatest mass extinctions, it would seem that the Earth is once again entering a brutal phase of upheaval in the climate and the composition of life. But let's go back to these periods of change that were decisive for the evolution of the fauna and flora as we know it today on our planet. We are in the second of the 6 systems composing the Paleozoic, the Ordovician, which lasts from minus 488 million years to minus 443 million years. This new period begins following the Cambrian extinction, probably due to an asteroid impact. At the beginning of this period, life existed only in the sea, a continental and shallow sea. The animal world was dominated by trilobites and brachiopods, which had a great evolutionary success in the Paleozoic. On land, it is nothingness. Oxygen is rare. Neither plants nor animals can develop. The supercontinent Gondwana includes all the continents of the southern hemisphere and is surrounded by the ocean Panthalassa, in which all living species are swarming. More than 490 million years ago, before the Ordovician period, the atmosphere was heavily filled with CO2, which induced a greenhouse effect, and consequently, very high temperatures. The oceans reached up to 45 degrees Celsius, or more than 113 degrees Fahrenheit. The photosynthesis reaction of the first living beings slowly pumped this CO2 out of the atmosphere. The seas cooled, which led to even more biodiversity. The Ordovician is more than favorable for the proliferation of life and evolutionary radiation. The number of genus and families almost quadrupled compared to the Cambrian. The species that dominates is that of trilobites. These marine arthropods can measure between 1 millimeter and 70 centimeters in length, the majority being between 2 and 7 centimeters, or almost 3 inches. This group is hyper-diversified, since it is not less than 18,750 species that are represented. The trilobites have a very specific anatomy. They are formed of 2 lateral lobes surrounding a median lobe, the longitudinal trilobation, and a head called cephalon. They have a solid exoskeleton. It is thanks to the molt that fossils of exoskeleton could be found thereafter. The main organs of the digestive system are located in the rachis. As in other arthropods, their muscles are striated, and the nervous system consists of a cerebral ganglion and an optic nerve, leading to the faceted eye. A voluminous dorsal vessel, made up of hearts, pumps colorless blood. Trilobites live only in water, with a great preference for the substrates constituting the bottoms of seas, oceans, and lakes. They feed mainly on invertebrates such as worms. Thanks to their legs covered with spines, the trilobites catch the worm and tear it before bringing it to its mouth. The trilobites laid eggs of a size of 200 micrometers. The genital pores are located at the back of their head. Brachiopods are lophotrochozoan animals, a major group of the mollusk class, the protostomians, which live exclusively underwater. Their shell has 2 valves with a particular symmetry, since instead of being positioned on the right and left, they are located ventrally. The peduncular valve and the larger, and dorsally, the brachial valve the smaller. The shell of a brachiopod is distinguished by the existence of a spiral brachial skeleton that lends itself to be the support of the lophophore, an organ near the mouth that contributes to the feeding of the animal. From the lophore, tiny filaments trap plankton and deposit it in the mouth. Brachiopods live permanently attached to their substrate. While everything is going well on Earth and life is proliferating, at the end of the Milky Way, a few thousand light-years from Earth, a star at the end of its evolution explodes into a supernova. Intense radiation energy emerges from its poles and releases a remarkable quantity of gamma rays. In 10 seconds, the explosion of gamma rays produces more energy than 1,000 suns. At a speed of 300,000 kilometers per second, or 170,000 miles per second, these rays cross the universe and reach the Earth. They first pass through the atmosphere and annihilate the air molecules. Only 10 seconds after the explosion, it is the return to calm, and yet the future of each species is now threatened. In the middle of the day, a second star shines next to the Sun. The supernova shines and will shine for a few more months before disappearing. Almost a third of the ozone layer has been destroyed by gamma rays. The ultraviolet rays of the Sun can now pass through the atmosphere. The Earth becomes a furnace, and the 50 times more intense sunlight is literally intolerable. The organic matter that plankton feeds on is totally burned by the sun. The plankton eaters are in turn deprived of food. The trilobite larvae that incubate in the surface waters do not survive the intensity of the solar rays. Their reproductive cycle is strongly compromised, and the adults become the prey of predators. The corals are decimated in just a few weeks. The whole food chain is disrupted. In the tropics, the rays are even more violent and cause the death of coral reefs. The DNA of all plant and animal species is damaged. The trilobites become scarce in their turn, and it is the beginning of the hunger for the big predators. Orthoceras and eurypteroids then fight a merciless war. Orthoceras are cephalopods with univalve shells that can measure from a few centimeters to 11 meters long, or from a few inches to 36 feet. They are the main predators of the Paleozoic era. The eurypterids are chelicate. Eurypterids are the largest arthropods to have existed on Earth. In the atmosphere, nitrogen and oxygen molecules are turned upside down and transformed into a harmful gas, nitrogen dioxide. This newly formed gas will spread in a layer, allowing harmful ultraviolet rays to pass through, but not the heat, which is, however, an elemental element for the maintenance of life. Temperatures fall, and a period of glaciation begins. The ocean, teeming with life, degenerates into an ocean of misery. The eggs laid in the cold no longer develop. Fortunately, since ultraviolet rays do not reach the depths, some species, such as eurypterids and nautiloids, take refuge in the shallows of the oceans in order to survive. More than 500 years later, the report is alarming. All forms of life on Earth are threatened, and a third of the fauna has already disappeared. 150,000 years later, the Ordovician fauna is dying slowly. The cold is intense. The planet is cooling down year after year. Famine is rampant, and predators are becoming scavengers. The glaciers suck the water out of the oceans until the water level drops by 50 meters, or more than 165 feet. The shallows dry up, and thousands of animals are left for dead. Nevertheless, some species manage to adapt to this new climate and these new living conditions, like the astrapis. With a small size not exceeding 15 centimeters or 6 inches, the astrapus is one of the few primitive fish species. It has a primitive backbone and a bony carapace that protects the spine. This animal is the ancestor of all vertebrates existing today, from birds to reptiles, through mammals and humans. The astrapus does not give the impression of being robust at first sight. It feeds on microbes and algae, and is a prey and not a predator. However, it will adapt and flourish during this period of glaciation. It adapts better to the cold than any other aquatic species and will follow the retreating ocean. Compared to carnivorous species that feed only on a particular prey, and therefore cannot survive when that prey disappears, the astrapus does not make the difficulty. It feeds on everything it finds. Very quickly, new varieties of fish arrive with new evolutions. The arteries and muscles will form the first gill, which will facilitate the sorting and absorption of food, and will later give the juice by taking the place of the orthoceras in the food chain. The cold persists and gigantic icebergs form under the surface, destroying everything in their path. The aquatic habitats are reduced. "500,000 years after the gamma ray burst, 2/3 of the animal world disappeared. Temperatures on the planet are finally starting to rise thanks to the gradual influx of CO2 from volcanoes. Little by little, the glaciers are melting. This new climate change upsets the species and pushes them to adapt again. 70% of the species disappear forever from the surface of the Earth following this extinction. During the millions of years that follow, the orthoceras is weaker than ever, but still present. It is smaller, weakened, and becomes an easy prey. On the contrary, the Eurypterid becomes a ferocious predator. With the decrease of the water level, the sea scorpion saw developing its lungs, allowing its blood to circulate through the tissues and to recover oxygen. It is now ready to venture onto the shore. It becomes as big as a crocodile and a feared predator. Acanthodians, fish cousins of astrapus, are also subject to extraordinary evolutions. They now have jaws that allow them to cut flesh from the carcass. They who used to feed on microbes and algae climb the ladder in the food chain. The planet is in remission, but the toll is heavy. It is gradually regaining its tropical climate and is seeing its water levels rise and aquatic habitats being recreated. All the fish we know today come from species that appeared at this time. But the Earth is about to undergo another cataclysm. During the Devonian period, the Panthalassa Ocean still covers a large part of the Earth. The supercontinent, Proto-Gondwana, is located in the south and is slowly moving northwards, while many islands and archipelagos are spread out on the equator. The climate is warm, between 25 and 30 degrees Celsius, or almost 86 degrees Fahrenheit. More than 200 million years have passed in tranquility, and in the vast ocean, animal life proliferates with abundance. Coral reefs cover millions of square meters. These ecosystems are populated by sponges, trilobites, mollusks, nautiloids, and brachiopods. Fish are also present and have evolved a lot. Placoderms impose themselves as the new species of fish on the front. Equipped with bony plates covering the front part of their body, they are now equipped with fins. A new space of displacement is offered to them. They can take height and escape the terrible scorpions of the seas. They are the first pelagic fish. Another new characteristic makes their strength, their jaw which articulates. From now on, they are able to tear and bite. Armed and harmful, placoderms are outstanding predators that hunt everything within their reach. From then on, aquatic vertebrates were divided into two major classes: fish with radiating fins, which still make up 50% of vertebrates today, and fish with fleshy fins, equipped with lungs, allowing them to breathe in the open air, and which would evolve much later into tetrapods. On land, vegetation evolved and became luxuriant thanks to a warm and humid climate. Ferns and lycopods abound, and tiny insects proliferate. In the absence of herbivorous species to limit the spread, vegetation abounds, and the first forests appear. The first broad-leafed plants appear, and by the same token, the photosynthesis reactions that contribute to enrich the atmosphere with oxygen. The first proto-legs develop on some fish, because in order to be protected from predators, they are led to take refuge in the waters of rivers, lagoons, or mangroves. In these shallow waters, roots and vegetation are intertwined, creating a cramped space in which the fish will have to use its fins differently. It clings, spreads, flattens, so much so that they are no longer useful for swimming, and evolve in a few million years into proto-legs. At the end of the Devonian, some fish with fleshy fins evolved into tetrapodomorphs, like the tiktaalik. It is an intermediate species between the fish and the tetrapod. It can reach up to 2 meters long and sees its body and its head flattened in order to keep the body in water, but to be able to take out the head to breathe, even if it can also breathe underwater. It is physically similar to the crocodiles of today. It is only 30 million years later that the first aquatic tetrapods were born, such as Ichthyostega, which will be one of the most important transitional links between marine vertebrates and exclusively terrestrial vertebrates. The first tetrapod to move on land arrived sometime later. It is Acanthostega. During several million years, it will make journeys between the aquatic environment and the land until becoming completely terrestrial. Scorpions and spiders also join these tetrapods outside the water. The Devonian extinction will extend over some 3 million years following a series of events. It all starts under present-day Siberia, in the heart of the Earth, where an ocean of magma is bubbling. A giant plume, an upwelling of hot rocks from the Earth's mantle, is being formed. It eventually breaks away from the magma, pierces the Earth's crust, and explodes. Extremely hot gases are projected onto the surface of the Earth. The water begins to boil, and underwater earthquakes annihilate the reefs. The colossal eruptions reach areas of 60 square kilometers with an energy equivalent to 1,000 nuclear bombs. In the surroundings, millions of fish die under the heat. The giant plume continues its conquest of the Earth. The prosperous animal kingdom that reigned is annihilated. The activity of the tectonic plates intensifies. The ocean floor cracks, and new oceanic crust and underwater volcanoes are formed. Another consequence of the plume is that it poisons the ocean, because when the molten lava comes into contact with the seawater, it releases many metals such as iron, magnesium, gold, and silver, toxic substances. Everything leads us to believe that the apocalypse is near. The Earth will never be the same again. "8,000 years have passed. The ocean continues its battle for survival without respite, but it is now the Earth's atmosphere that is under attack. Thousands of tons of toxic gases, such as carbon dioxide, are slowly released into the air, loading it with greenhouse gases. The temperature rises. The ocean currents, which were previously assured by a redistribution of heat, stop, and the world freezes. The water of the oceans reaches 32 degrees Celsius or 90 degrees Fahrenheit. The aquatic environment dies. The trilobites do not survive. 250,000 years later, the giant plume continues to trigger volcanic eruptions. The vegetation takes advantage of these favorable conditions for its proliferation to develop in abundance. The planet becomes a paradise for plants that need sunlight, carbon dioxide, and water. Vegetation flourishes, and many leaves fall to the ground. This accumulation of plants rots over the years and forms the first layer of humus on the planet, like a rich and deep soil. The darker part of the story is that when it rains, the soil is washed into the ocean. The algae absorb the nutrients and grow unchecked. The seas become saturated with plants. North of the equator, the ocean is nothing but bacterial sludge and looks like a cemetery. A few Dunkleosteus, large arthrodire placoderms, fight against starvation, but their appetite and the lack of food forces them to cannibalism. Even if the animal kingdom seems to be dying out, some of the more resistant species are developing astonishing ways to adapt to their new world. This is the case of the Moderpacis in Australia. This small fish that fits in one hand is able to crush a shell with its teeth, but its strength lies elsewhere. This viviparous fish protects its young in its abdomen, a fundamental characteristic for its survival at one of the worst times of the planet. 750,000 years after the giant plume, eruptions are now hitting the Earth. A gigantic volcano is preparing. It is in present-day Western China that the eruption takes place. Lava geysers reaching hundreds of meters in height gush out. A cloud of ash is formed on the whole sky, which takes a reddish-orange color. A black veil hides the light. While the Earth had been functioning as a huge greenhouse for several thousand years, the volcanic gases that now mask the sun's rays will plunge the planet into a volcanic winter. The temperature of the oceans will drop from 32 to 21 degrees Celsius, or from 90 degrees Fahrenheit to 70 degrees Fahrenheit. Fish eggs and plankton are eradicated. In Greenland River, tiktaalik survive, but the first snowfall will surprise them. The Earth, which was tropical, cools down, and the frozen waters will bring the tiktaaliks to their loss. They die out little by little, until they disappear completely. The volcanic winter ends 1.5 million years after the beginning of the plume. The plume is finally extinguished. 70% of the species have perished. The ocean is now a gigantic empty bathtub. The reefs that once covered 5 million square kilometers are reduced to a few thousand. The Earth is devastated, emptied. It becomes a hostile world. Microscopic bacteria and algae invade the ocean floor, so much so that one would think one was back in the Precambrian era. The trees still present will produce oxygen and contribute to the rebirth of the Earth. Temperatures stabilize, and life diversifies again, especially in the tides. During the Permian, the two continents, Laurasia and Gondwana, merged to form a new supercontinent, Pangaea. This movement of the continents modified the climate, giving the Earth a completely different shape and allowing new life to develop. Immense arid deserts and mountain ranges cover the surface of the planet. The water level decreased considerably, and a new ocean was formed, the Tethys, from east to west of Pangaea. Temperatures on the surface of the Earth vary between 0 degrees Celsius and 40 degrees Celsius, or range between 32 degrees Fahrenheit and 104 degrees Fahrenheit in a single day. The forms of life are diverse. We find plants, reptiles, amphibians. At the aquatic level, mollusks, echinoderms, and brachiopods develop. Animals adapt to these new climatic conditions and develop ways to regulate their body temperature. Dimetrodon and Edaphosaurus, mammalian reptiles, develop dorsal veils and thermoregulatory power that allowed them to vary their body temperature by absorbing or evacuating heat. Others will mutate and evolve, like the therapsids, by developing a fur as a means of protection. Bipedal and flying animals made their appearance. Two crust bursts out into the open. The ground splits in two for about 30 kilometers, that is to say 18 miles. It is a real tidal wave of liquid fire. A lava flow quickly covers the equivalent of the surface of Florida in only 48 hours. And it doesn't stop there. While most volcanoes explode and stop between their periods of activity, the eruption of the Siberian Traps is manifested by a basaltic outpouring that continued over the years. Pangaea is soon completely won by the anger of the volcano, installing a dangerous natural imbalance. Life near the traps is instantly decimated. The surviving animals try to flee far from Siberia, but the consequences of this catastrophic event will not let them rest. 10 years after the eruption, volcanic gases that have accumulated in the atmosphere are causing climate changes. Carbon dioxide and sulfur dissipate from the Earth's crust. Sunlight becomes obscured, and the trapped heat results in decades of unstable weather patterns. The alternation of cooling and warming phases makes the balance of life impossible. All areas of the Earth are affected. In South Africa, 24,000 kilometers, or 15,000 miles from Siberia, survivors are beginning to struggle to breathe. The temperature rises a few degrees and the oxygen level drops. The respiratory system of listosaurs or gorgonopsians cannot withstand the lack of oxygen. Predators and prey share the same battle. The Thrinaxodon, a small animal that one would have thought easily defeated, seems to be favored by evolution. It shows a great resistance to heat because of its small size and faces air pollution thanks to the bony structure of its face, which allows it to breathe and chew at the same time. Its community life also allowed it to enjoy a solidarity during this cataclysm and to lighten the burdens such as feeding or defending itself. 25 years pass after the eruption, and the molten rock continues to spread. When it comes into contact with the air, it congeals into a black mountain on which no life is possible. The animals that live in these regions must leave, Some die of hunger. Half of the Gorgonopsians are decimated in northern Asia, as a new catastrophe is brewing. Sulfur dioxide, the Thernaxodon, manages to find shelter. 50 years after the beginning of the cataclysm, the volcanic eruptions remain. The Siberian traps are located on a coal reserve. The methane it contains is suddenly released, and much more powerful than carbon dioxide, it contributes to the greenhouse effect. The warming accelerates. The plants, which are the base of the food chain, perish under the heat, and famine sets in. Large herbivores like Dixo. Some species take advantage of this hostile universe, warm. The Thernaxodon becomes a scavenger and feeds on remains, insects, and amphibians. 10,000 years after the eruption, life on Earth is on the verge of total extinction. The floods linked to the spring monsoon carry millions of tons of dead plants to the sea, transforming it into a huge landfill that putrefies under the effect of the heat. Oxygen in the ocean becomes scarce, and the rocks become black. The ocean floor is covered with corpses. Only the bacteria survive. The majority of the species that dominated the marine ecosystem disappeared. Extinction. The lava flow is now 1,600 meters, or 5,200 feet deep. A tiny fraction of the species that still survive are trying to adapt again and again. The Lystrosaur is now smaller and able to survive without food or water for longer. Their path crosses that of another herd, and their meeting will give birth to a new. 1.2 million years after the eruption, all forms of life seem extinct. All, or almost. A few survivors manage to adapt to this hostile environment, which will later give birth to crocodiles as born. The Thernaxodon also survived the cataclysm, which is crucial for the subsequent emergence of man. The Permian mass extinction is the most devastating in the history of the Earth. 95% of all life forms disappear, including 70% of terrestrial species, such as vertebrates, plants, and insects. The Permian extinction ends the Paleozoic era. We are now in the Mesozoic era, also called Age of Reptiles, whose first period is the Triassic. The Triassic period begins after the Great Permian extinction, which considerably reduced biodiversity, since 95% of marine and terrestrial life disappeared forever. The supercontinent, Pangaea. The vast Panthalassa Ocean surrounds it and contributes to the humidification of the coastline. The interior is dry and arid. It is hot on Earth. These mountains blocks the clouds, which causes precipitation on well-targeted regions. As a result, Pangaea has two types of climate: a hot and humid one, where clouds are present in the north, and a hot and dry one, where clouds can't go in the south. The northern slope of the Hercynian chain is much more favorable to the development of vegetation and the animal world. In terms of vegetation, we find mosses, seed plants, ferns, and other horsetails. The plant kingdom was less affected by the Permian extinction than the animal kingdom, but still witnessed the disappearance of Devonian Sigillaria, characterized by their fossilized trunks, and lepidodendrons, among others. It will take only a few thousand years for the flora to be abundant again, and for the vegetation to green up on Pangaea. On the fauna side, the disappearance of the vast majority of species has left a large number of ecological niches free. The surviving species are brought to move. The animals will conquer this new environment, In the seas and oceans, the previous extinction had spared no one, since 95% of the species in place were led to disappear. Life has nevertheless resumed its course, and the oceans are gradually repopulated with new varieties of modern corals, mollusks, and many species of fish. Within a few thousand years, life was once again teeming under the waters, but it would never be as abundant as during the Paleozoic. Chondrichthyans, distant cousins of sharks, appear. These fish are characterized by paired fins, scales, and a skeleton composed of cartilage and not bone. Hybodonts are also found in the marine environment. They evolved clearly throughout the Triassic period. At first they were small, about 20 to 30 centimeters or 12 inches, and fed on small prey. A few million years later, they adapted to the salinity of the coastline and diversified, reaching sizes of up to 3 meters long, or more than 9 feet. They developed teeth that allowed them to tear and also to crush. They then occupied the top rank of the oceanic food chain at that time, before the arrival of marine reptiles. It was during the Triassic period that marine reptiles developed and flocked to marine and oceanic waters. Several families of marine reptiles arose, but some did not last, such as placodonts, marine reptiles that fed on hard prey and crustaceans, or thalattosaurians, reptiles with long paddle-like tails and slender bodies. The marine reptiles that made a permanent water, like the present dolphins. On land, the last survivors of the Permian extinction are the most widespread. The Rauisuchians, archosauromorphic reptiles, are at the top of the food chain. The most basal of the group would give rise to the archosaurs and then the pterosaurs, insectivorous reptiles with a wingspan of about a meter, or 3 feet, that flew. The crocodilians. This lineage of archosaurs gave birth to the first dinosaurs in the Upper Triassic. The latter did not yet reach colossal sizes. Some were small, like the Argentine Euraptor, which was 1 meter long, or almost 3 feet long. The largest and most numerous are the Plateosaurus, herbivorous dinosaurs measuring up to 10 meters long, or more than 30 feet long. Mammals managed to survive the Triassic period without difficulty. The most numerous are the therapsids, the diconodonts, and the Lysowicea. This animal, weighing between 5 and 6 tons, had a size close to that of Asian elephants. It is the largest of its environment. Let's remember, during the Permian extinction, the Siberian traps let out lava and toxic gases on the Earth for 1 million years. Now the surface of the planet is calm, and the hostile desert that the Siberian traps left behind is once again welcoming and lush to life. But deep in its bowels the Earth still boils. The forces that brought Pangaea together a few million years ago are breaking it apart. The gradual displacement of the continents is causing the magma that makes up the mantle of the Earth's crust to flow, and when these forces break up Pangaea, lava will gush out in considerable quantities. This is the beginning of a new mass extinction. For several weeks, a rumbling has been heard and felt. In a fraction of a second, Pangaea is torn apart. Geysers of burning steam come out of the bowels of the Earth and shoot up to more than 1,500 meters of altitude, or 5,000 feet of altitude. The gigantic eruptions of burning steam that leads to the division of Pangaea and the formation of the Atlantic Ocean basin. The volcanic eruption is triggered, lava gushes out through land cracks, and the magma spreads like a gigantic fire wave. The cracks can reach up to several 20 kilometers or miles in length. They are literally waves of flame that run until they reach animals and vegetation, swallowing everything in their path. Nothing has ever been comparatively so violent since the birth of humanity. The herbivores rush to flee, but the quills on their backs protecting them from predators slow them down, and the lava catches up with them. For months the lava flows. The animals flee, but have nowhere to go. Faced with this critical situation, some are better equipped than others to adapt to change. This is the case of the Styracosaurus, one of the very first dinosaurs. It is 50 years past during which volcanic eruptions follow one another. A layer of lava gradually covers the surface of the globe. These eruptions produce a lot of gas, dissolved in the magma. When they rise to the surface, millions of tons of noxious gases are released into the atmosphere, and the carbon dioxide level increases. Temperatures rise considerably. The heat is so great that it becomes suffocating, so much so that marine animals also suffer from the heat wave. The Rutiodon, a kind of archosaur, lives in the water, but is forced to venture onto land to lay its eggs. This particularity of his species condemns him forever. Feeding itself becomes an ordeal for all of them, until they eat their offspring. A few decades later, the heat is still imposing, and now the concentration of oxygen in the air is very low. It would be impossible for modern man to breathe in such conditions. Desmatosuchus will bear the brunt of this low oxygen concentration. Although they have never feared predators thanks to their imposing carapace, they are in a bad position this time because their respiratory and pulmonary capacities are very limited. Every movement is laborious for them, and they start to stay localized in smaller areas. The lack of oxygen also affects the reproduction, because the eggs are not oxygenated enough for the embryo to develop. The births decrease, the survivors and the newborns become weaker. The population of Desmatosuchus eventually becomes extinct, which benefits the Styracosaurus. The latter does not have the same physical structure. Its limbs are aligned with the rest of the body, and therefore do not interfere with the internal organs. The lungs unfold fully, and it has less difficulty breathing. Styracosaurus also has extra air pockets, like birds and dinosaurs, creating a continuous flow of oxygen through the respiratory system. This is how a bird that breathes the same air as a human will absorb 30% more oxygen. The years go by and cracks appear again and again. The surface of Pangaea is dying, and a new world is slowly taking shape in organic matter. The ocean world is similarly impacted. The water, in turn, becomes acidic, and the plankton, the basis of the food chain, dies. Then, the fish and all the creatures that feed on them succumb in turn. Eudomorphindons go along the rivers and lakes to find food, but they will have to make do with the only corpses rotting on the ground. It is now 70,000 years since the catastrophe began, and the Earth has a new face. Many organisms have disappeared, and others are taking advantage of the situation to spread, such as bacteria. These bacteria transform the ocean into a dirty place. The sky turns yellow, and the smell of sulfur tendons that separate the lungs from the rest of the organs, the diaphragm. This makes it easier for it to breathe, despite the toxicity of the air. The Megazostrodon also has a major advantage for its survival. It is one of the first animals to nurse its young. The female, therefore, only has to draw on her own resources to feed her offspring, while others have to find food for them. 250,000 years have passed since the eruption, and Pangaea is unrecognizable. Fissures run through the earth on both sides, and molten rock still flows from them. The quantity of magma poured out will reach a total of about 2 million square kilometers. Desertification spreads over entire regions. In some rare regions where life remains, the Styracosaurus continues to evolve and find its place. In addition to its advanced pulmonary system, it now incubates its eggs. This body contact provides temperature regulation and protection. The new generation emerges stronger and more robust. Dinosaurs are becoming more and more numerous. It will be only 500,000 years after the beginning of the events that the eruptions stop. The shifts in the Earth's crust definitely broke up Pangaea and divided distinct continents as we know them today, which favored the opening of the Atlantic Ocean. The 3/4 of the terrestrial fauna disappeared forever, affecting more particularly the herbivores, like the Desmatosuchus. Underwater, the disaster is also without appeal. The coral reefs are almost all destroyed. It will take 600,000 years for the Triassic extinction to end. It is still as hot as ever. The air is barely breathable. The carbon dioxide level is at its highest. But our world as we know it today was born. The Styracosaurus has adapted to the worst possible conditions, and now the planet is his and his kind. They multiply and invade the land, creating new habitats and new species. Alongside these giant lizards, we find the ancestor of the current mammals, the Megazostrodon. They will evolve during the next thousands of years. We are now in the Cretaceous period. Seen from the sky, the Earth appears very familiar to what we know today. The fragmentation of Pangaea draws the features of our current continents. The planet has no ice caps, so the climate is always warm. The oceans are 200 meters higher than today's level, more than 650 feet higher. Ferns, conifers, and flowering plants dress the landscape. Reptiles still dominate the aquatic environment, although one of the largest groups, the ichthyosaur, disappeared for reasons that are still quite mysterious. In the air, creatures reach impressive sizes, like the Quetzalcoatlus, with its 15 meters or 50 feet wingspan that fly majestically. The pterosaur has to be careful. It is less and less present on this land of giants. In fact, on dry land, the gigantic dinosaurs are the group of animals that has dominated and reigned supreme for several million years on all continents. Well established, they evolved and diversified, and new species emerged, such as the Tyrannosaurus, the famous T-Rex. With a long, powerful tail and a massive skull, it measures more than 13 meters or 40 feet and can weigh up to 8 tons. It is the largest carnivore that has ever existed on Earth, and by far the largest of its time. Alongside the dinosaurs, the mammals still have a place. Smaller in size, they are no bigger than a mouse, while the smallest dinosaur measures 1.20 meters, or 4 feet. 2 million species of animals lived together at that time. A few 100,000 years before the famous cataclysm, an exceptional volcanism took place at the level of present-day India. Its name? The Traps of Deccan. Over more than 1 million years, lava flows fall on the surface, covering more than 2 million cubic kilometers, reaching in some places more than 800 kilometers or 500 miles long. These basaltic flows are accompanied by emissions into the atmosphere of large quantities of carbon dioxide and sulfur dioxide, 2 gases that can modify the climate. These emissions of sulfur, after conversion to sulfate aerosols, would have induced, 65 million years ago, brief episodes of global cooling, while CO2 would have caused a warming of 3 degrees Celsius or 37 degrees Fahrenheit in the longer term, most likely contributing to the most famous biodiversity crisis in the history of the Earth that will follow. A few million kilometers from Earth, in the asteroid belt between the orbits of Mars and Jupiter, one of the celestial objects goes off course and heads for Earth. Launched at several kilometers or miles per second, the asteroid, up to 10 kilometers or miles long, lands on the Earth like a bomb and forms a crater 50 kilometers or 30 miles deep in the Yucatan Peninsula in Mexico. The energy released by the asteroid is equivalent to 100 million megatons. In less time than it takes to say it, the water within a radius of 60 kilometers or 37 miles turns into vapor, suddenly killing millions of lives. Animals near the impact bridge do not have time to feel the shock, as they are hit at a speed far faster than their reaction time. The vaporized rocks form a hot cloud and quickly move towards the ocean. This is the shock wave. Everything in its path is evaporated. Part of the Earth itself is transformed into vapor over the entire continental United States. Even the mighty Tyrannosaurus will not withstand the shock wave. The only survivors are those who manage to take shelter in caves. Fires break out. North America is like a giant inferno. Prey or predators, parents or children, no one is spared. Our distant ancestor, the Purgatorius, a mammal, stays in his burrow. Its small size allows it to find shelter, to take cover, and to protect the survival of its species. 10 minutes after the impact, the shock wave has released all its energy. But the consequences start to be felt. The Earth shakes. Rumblings are heard. It is an earthquake of very strong causes landslides. The tremors and aftershocks lasted several days. The asteroid continues to cause destructive phenomena. Less than an hour after the impact, a giant tsunami is heading towards the coast at a speed of 1,000 kilometers per hour, or 620 miles per hour, the size of a mountain range. On the coast, animals see the ocean receding, then a line on the horizon growing closer and closer. The tsunami hits the land, catching trees, animals, and debris, and scattering them across the landscape. This wave, which measures several hundred meters in amplitude, or almost 1,500 feet high, sweeps the planet, not sparing aquatic animals either. The mosasaur, which can measure up to 17 meters or 55 feet, is caught by the current and pushed back to the shore, where it will await certain death. The wave submerges the lowlands, digging holes more than 300 meters or 1,000 feet deep, after which it retreats with such force that it carves a new landscape. A few hours later, the ocean calms down and the survivors emerge from the rubble to contemplate the extent of the damage. But before they could come to their senses, another consequence of the impact hit. When the asteroid hit the Earth and dug the crater, millions of tons of rock were propelled into space. They are now falling back on the planet, forming the largest meteor shower of all time. Pieces of the Earth's crust are crossing the atmosphere again for several hours. The planet is in flames. All creatures are harmed. The temperature climbs in a few hours, and the heat becomes unbearable to the point that in some places the rivers start to boil. The Earth is unrecognizable, and yet some specimens resist this apocalypse. The Purgatorius takes refuge underground, while on the surface, the dinosaur world collapses. It waits for calm to return, and organizes itself by rationing its food. In the Yucatan Peninsula, the crater is a caldera. Mountains rose to 5,000 meters above sea level, more than 16,000 feet high. 1 year after the impact of the asteroid, the Earth is almost emptied of all life forms. 70% of the species disappeared during this fifth mass extinction. Some of the smallest animals were able to survive, like all those that exceeded 25 to 30 kilograms, or 50 pounds. The ocean was also deprived of large marine reptiles and most fish and plankton. The small mammals that were hiding eventually come out. Turtles, snakes, and crocodiles have also saved their skins by burrowing deep into the ocean and by their ability to hibernate and fast for extended periods. The Purgatorius, one of the oldest representatives of the primates, can have his revenge. He who was the prey of the dinosaurs can now roam without fear on this new land. Its important radiation in the era that followed, the Paleogene, played a role in the emergence of mammals and the later appearance of Homo sapiens. Mammals become the dominant species. The only surviving descendants of the dinosaurs are the birds. This is the last great extinction that will take place until today, and it is thanks to this incredible adventure that modern man has been able to take his place on Earth. It all began about 200,000 years ago. A new species with a precarious survival appears. In small numbers and only localized on a small part of East Africa, they are at the beginning only a few thousand couples. In spite of its slowness and its weakness, this species shows itself fundamentally resourceful. None of the constraints of the natural environment seems to slow it down. It crosses rivers and mountain ranges, and gradually colonizes other regions where there are prey and climates suitable for its survival. Wherever this species settles, it adapts and reinvents itself. This species, our species, is expanding its range. On its way, it crosses other beings, many animals which can reach twice, 10 times, or even 20 times the size of its members. Nevertheless, it reproduces faster and is sufficiently intelligent to ensure its survival. It will then go beyond the water's edge, crossing seas and oceans. The story goes on for thousands of years until our species spreads over almost the entire Earth. Homo sapiens reproduces at an unprecedented rate. For the first time in the history of the Earth, a living being changes the structure of the organic world on a global scale. Man eliminates forests in order to feed himself through agriculture. He contributes to the transit of animals and plants on both sides of the planet, and thus redistributes the components of the biosphere. But the most important transformation lies in the discovery of underground energy reserves, which leads to an evolution of the composition of the atmosphere. Such events, involving such violent changes that threaten the diversity of life, had previously occurred only 5 times. 5 catastrophes so damaging that they are classified in a very special category: mass extinctions. It is too early to say that human behavior will cause identical consequences, but some scientists agree on the qualification of sixth extinction. While for more than a century man has been improving his quality of life and his life expectancy, how can we imagine that our planet Earth is doing so badly? A mass extinction, or biological crisis, refers to an event marked by the sudden and simultaneous disappearance of more than 60% of the biodiversity, whether animal or plant, on the entire planet. It is relatively short compared to the geological timescale and corresponds to a few million years. In spite of its intensity, a mass extinction gives the chance to certain forms of life to develop without their usual predators. Biodiversity is transformed, and a new equilibrium is created. As during the biological crisis of the Cretaceous, Paleogene, the disappearance of the dinosaurs left the field free for certain species, ancestors of man. For a few decades, studies have been carried out in order to take stock of the species that are disappearing. 1 million animal and plant species are threatened with extinction out of the 8.7 million species listed. 2/3 of animal species could disappear in less than 80 years. The history of the Earth has always been marked by catastrophes and devastating biological crises. Life oscillates tirelessly between periods of intense development and almost total extinction. But today, the beginnings of a new extinction seem to be looming large. Are we on the verge of a 6th mass extinction? The future will tell us.